Okay, so this is going to be a review for the Algebra 1 exponents, and I'm just going to use the quiz review to incorporate all of the rules that go along with this. So as we look at number one, first what you have to understand is when you are multiplying these monomials, so by monomial I mean these are monomials, when you're multiplying those and the bases have exponents, you have two things here. First, you have coefficients, and then you have bases. Okay? Here are coefficients. We're going to multiply. So we're going to multiply 3 times 5 to give us 15. Then we have bases. Although here, notice we have an a squared and an x to the 6th. Those are different. You cannot combine unlike bases. So because you cannot combine unlike bases, you're left with a squared x to the 6th. Number two, here we have power to a power. How do I know that I have power to a power? Because I have this monomial inside of parentheses with an exponent of 3. My first biggest recommendation is to look through and make sure every single piece of this has an exponent. Even your coefficients. If you have a coefficient, your coefficient has an exponent of 1. What you are then going to do is distribute this exponent on the outside, to 3, to every exponent on the inside. So you're going to multiply the 3 times 1, giving you 2 to the 3rd. Then you're going to multiply 3 times the 2, giving you x to the 6th. And then 3 to the exponent of 4, giving you y to the 12th. Because 2 to the 3rd is going to be a small number, you can simplify that, giving you a final answer of 8x to the 6th, y to the 12th. Now, for example, if that was like 2 to the 22nd, you wouldn't do that. You would just leave it as 2 to the 22nd. But because 2 to the 3rd is not going to be a terrible number, you can simplify that to 2 to the 3rd is actually 8. Number 3. Again, with number 3, we have coefficients, and then we have bases. Notice here I have a base of a and a base of a, which means that we can then add the exponents. So first I'm going to multiply my coefficients. So 1/3 times 9 gives me 9 over 3. And then I have a base of a. I have to multiply or add my exponents. So I get 9/3 a to the 8th. I can simplify 9/3 to 3 over 1 a to the 3rd, or a to the 8th, and then just 3a to the 8th. Number 4, again, we're doing power to a power. Now, I do understand that I have a negative exponent here, but I'm going to take care of that later. One thing I do want you to recognize is that as we go through this term, notice my z does not have an exponent. For aesthetic purposes, I'm going to put a 1 there. All right? Now, I'm going to distribute the negative 3 to the x squared, giving me x to the negative 6th. Now what I'm going to do is I distributed the negative 3 to the negative 1, giving me y to the positive 3, and then negative 3 to the positive 1, giving me z to the negative 3rd. So now I've distributed the outside exponent, and what I'm going to do now is to continue simplifying because I'm not allowed to have negatives as an exponent. So what that's going to do is to send any base that I have in the negative exponent to the bottom. And what I mean by that is like to the bottom part of a fraction, right? Or you would say it'd be the reciprocal. So technically, I could say this would be 1 over x to the 6th times y to the 3rd over 1 times 1 over z to the 3rd. Multiplying fractions or multiplying straight across, we multiply straight across, giving me y to the 3rd, then multiply straight across here, and I get x to the 6th, z to the 3rd. And again, I can't combine these on the bottom. I can't combine these two things on the bottom because they're different bases. So they just stick together like that. Okay, let's keep going. Number 5. Here, as I look across, I see that my 3, my coefficient, does not have an exponent, so I'm going to put an exponent of 1 in there. Again, I have all of this in parentheses raised to a power, so I'm going to multiply the 2 on the outside to every exponent I have on the inside. So 2 times 3 to the 1st gives me 3 squared. 2 times a to the negative 3rd gives me a to the negative 6th. 2 times b to the 2nd gives me b to the 4th. 2 times c to the 0 leaves me with c to the 0. Now, I know that anything to the 0 power turns into 1. So now I can continue to simplify this. Notice we have this negative exponent. So that's going to drop my a to the negative 6 to the bottom. So it's going to look like 3 squared. B to the 4th. You do not have to write that 1. So that just kind of disappears. And my a to the negative 6 goes to the bottom, becoming a to the positive 6th. You could, if you wanted to, you could simplify that 3 squared, giving you 9b to the 4th, a to the 6th. Okay. Here, let's take a look. We have coefficients. And then we have bases that are the same. First thing I'm going to do is to multiply my coefficients, give me negative 15. My bases are the same, so it leaves me with x. And I'm going to add my fractions, my fraction exponents. So 1/2 plus 2/5. You cannot add fractions with unlike bases, so I'm going to use a common denominator of 10. So if this becomes a 10, this becomes a 5. If this becomes a 10, this becomes a 4. So when I add these two together, I get 9/10. Now, you leave, this is your answer. You leave it because this negative does not make it move. Only negative exponents make it move to the bottom. Okay. I'm going to white this out, I think. Okay, so I'm going to white this out. Okay, so a couple ways that you could do this problem because there's a lot of stuff going on. Okay, so first thing that you could do is here, notice we are dividing powers. So I want you to think about splitting this into different pieces. So here we have this part. I don't want to do that. Let me go back one. Thin this out. You have this piece, and then you have this piece. Okay. When you have 10, this piece right here, 10 over negative 2 simplifies to negative 5. Then we have a base of A. A base of A, and we have 5 minus a negative 2, because when we divide powers, we subtract our exponents. So 5 minus a negative 2. And then we have our last one, b squared over b to the first. So b squared minus 1. Okay. Now, all that is going to be squared. So let's do a little more simplifying. Negative 5. A. 5 minus a negative 2 gives me a to the 7th. And then b squared minus 1 gives me b to the first. All that is going to be squared. So now let's go ahead and do that. So I get negative 5 squared a to the 14th b squared. You can simplify that piece, giving you negative 25a to the 14th b squared. Now, you could have also distributed that to everything in here and then simplified. It's really up to you. I find it easier to simplify what's inside first and then apply the power to the power. But again, it's what makes you comfortable. Okay. Here, we are again dividing. So, a couple different things. We have this. And then we have our bases of x. And then we have our bases of y. We're going to do this in pieces. 3 over 6 simplifies to 1/2. Okay. X to the 4th. We have x to the 4th minus x to the 6th. giving me x to the negative 2. And then I have y, and I have negative 2 minus a negative 1, turning that into a positive. Y to negative 2 plus 1 gives you y to the negative 1. Okay, one thing I want you to notice. Notice when I did the x and I got the x to the negative second, that I left it up top. And I got this y to the negative first, and I left it up top. Because as you go through this, as you simplify these, you always assume that they're going to be on the top part of a fraction unless otherwise stated. So what I'm going to do now is, so now I can continue on and I can continue simplifying. I still have this 1/2. This x to the negative 2 is going to go down to the bottom to join the 2. And this y to the negative first is also going to go to the bottom. And you're going to get a final answer that kind of looks like this if you wanted to rewrite it. This is absolutely correct. If it bugged you that the 1's not in the middle, then you can rewrite it like this. Okay. Okay. Again, here, a couple things that you can recognize. One, there's nothing that you can simplify inside of these parentheses. As you look here, like the 8, or like there's nothing to simplify with that. You're not dividing it by anything. Here you have x as a base. Here you have y as a base. Nothing's going to simplify out. So our next option is to then distribute that negative 1 on the outside. I am going to put a 1 here above the 8, and I'm going to distribute this negative 1 to every exponent. So I end up getting 8 to the negative 1, x to the positive 2 over y to the negative 5th. Now we can kind of clean things up a little bit. And by doing that, my 8 is going to drop to the bottom to make that exponent positive, giving me 8 to the first. The x squared is going to stay because it is positive. And then my y to the negative 5th is going to move up top to then make it positive as well, giving you a final answer of x squared y to the 5th over 8 to the first. Okay. Here, recognize that we have multiple coefficients. We have a negative 3, a 6, a 2, and we have bases, but notice that the base is the same throughout. So we only have one base. I am going to add something to this before I get started, which is a 1 to that p in the middle. Okay. Let's go ahead and multiply our coefficients. So negative 3 times 6 gives me a negative 18. Negative 18 times 2 gives me a negative 36. And then we have our base of p. Negative 3 plus 1 is a negative 2. Negative 2 plus 3 gives me a positive 1. So this would be your final answer. No simplifying needed. All right, doesn't this look super fun? All right, again, a couple of things I want you to recognize. Here, we have 3 technically over 1, right? Because any number over itself, or any number over 1 is just itself. And then we have a base of x, and then a base of y. I am going to add a 1 here. 3 over 1 simplifies just right to 3. X over x, so I get a base of x. 1/2 minus 1/3, so 1/2 minus 1/3. Get a common denominator, so let's use a common denominator of 6. This becomes a 6, that becomes a 3, this becomes a 6, that becomes a 2. Okay, so 3/6 minus 2/6 gives me 1/6. And then let's do our y's. So we have a base of y. And we have 1 minus 2/3. Any number over itself is 1, so I can change this into 3 over 3. 3 minus 2 is 1. You get 1/3. So you get a final answer of 3x to the 1/6, y to the 1/3. Okay. Here again, we're just going to simplify. Ooh. And then, so 8 over 16 simplifies to 1/2. And then we have a to the 2/5. So we have 2/5 minus 3 over 1. We can't do that subtraction because we need a common denominator. I'm going to choose 5, so this turns into a 5. That turns into a 15. 2 minus 15 gives me a negative 13 over 5. Am I allowed to have a negative denominator? No, I am not. So this becomes 1 over, the a will come down to join the 2, so I get 2a to the negative 13 over 5. Okay. Now I'm going to do this one the other way. So what I'm going to do first is I'm going to now distribute I'm going to distribute the power to a power first, and then we'll simplify. So I'm going to distribute the 3. So I get 3 to the 3rd, x to the 0, y to the 6/3, over x to the negative 6th. I can simplify. What's going to happen here is this x to the negative 6 is going to come up. So I can do 3 to the 3rd, x to the 6, x to the 0, y to the 6/3 simplifies to 2. Again, a little more simplifying here, but not really, because we know that anything to the 0 power is 1. So I get 3 to the 3rd, x to the 6, y squared. And if you want to make your professor happy, you simplify 3 to the 3rd, giving you 27 x to the 6, y squared. Okay. Oh, I missed some. And I like this one, so I'm going to go back and do 10. So let's look at 10. 10's so easy. Why is 10 so easy? What do we see with our eyeballs? We have a 0 to that whole entire thing, which turns whatever I have on top, it turns this entire thing into 1. So I get 1 to negative 7x to negative third. Now, where most students are going to make the mistake is when they go to simplify this a little bit. This has its own exponent. Its own exponent is 1. So when you simplify this, only the x to negative 3 is going to move. So you get x to the third over negative 7. And then we might as well do this one while we're here. All right. Let us distribute all the things. So I'm going to add a 1 to that coefficient. Why? Because that way it reminds us that we're going to distribute the negative 2 to all the things. So we get 2 to the negative 2. Distribute again. I get x to negative 8th over, distribute again, y to the 6th. As we continue on, both on the top are negative. We have negative exponents on both. So both are going to move to the bottom. Well, if I move both to the bottom, that leaves the top blank. Well, not necessarily, because I can fill that in with a 1. So I get 2 squared x to the 8th, y to the 6th. And if you want to make it look a little cleaner, you can do this. Final answer. All right, let's take a look at the other page. Okay. Here, I want you to recognize a couple things here. Like this. I want you to start realizing that these are all separate pieces. Okay? These are all separate things, and technically I can put that over 1, right? So you're going to get 6 over 1, and all this is held together by multiplication, times, what is anything over itself? So x over x is just going to simplify down to 1, because anything over itself is 1. And then y to the first over y squared simplifies to y to the negative 1. Kind of mush this all together. So you get 6 to the 1. This is going to move it to the bottom. So you get 1 over y to the first. Multiply everything straight across. You get 6 over y to the first. Okay. Here we're just going to move some stuff around and simplify. Again, recognize all these are separate pieces. So they have to be handled individually. I'm going to add a 1 here. So I get negative 2 times x to the negative second can be turned into 1 over x squared. Y to the 0, anything to 0 power turns into 1, and z squared. Notice all of these, so all of these 3 terms are going to be left up on the top part of our fraction. The only thing on the bottom is going to be that x squared. If you wonder why this is going to work, is because technically anything over, I can turn anything into a fraction by putting it over 1. So now we multiply straight across. I get negative 2z squared over x squared. That's it, you're done. Okay. Scribble some of this out a little bit. Okay. So, as we go through this, a couple things that we can add to this. I'm going to add a 1 right here and a 1 right there. Again, aesthetic purposes. We can distribute first. We can distribute this 1 first if we like. And if we do that, we get x to negative 1. Y to negative 3. 4 to negative 1. Y to negative 1. Z to the 0. Oh, poop. We were supposed to put that stuff in. All right, I'll go back and do that. Okay. So now we're here. I'm going to move. Let's look at this for a second, right? So I have 4 to the negative 1. This is going to move up. This is going to move down. So 4 to the first. X to the first. Here we can simplify. So you have y to the negative. So you have y to the negative second. Okay. So from here, I did it again. Anyhow. So from here, you get 4 over x to the first, y to the second. Okay, now I'm going to go back. I'm going to leave this and try and do the whole thing. All right. Now, let's go back and do some of this a little bit because you're supposed to stick stuff in. So y equals negative 2. All right, so here. Okay, so if we plug in negative 2, you get 6 over negative 2, simplifying to negative 3. Let's look at the next one. All right, so we have to plug in 1 and 3. So we get, let's begin, 1 and 3. So you get negative 2 times 3 squared over 1 over 1 squared. Negative 2 times 9 gives you a negative 18 over 1. All right. And then we get 4 over 1 times negative 2 4 over -2, giving you -2. Okay, let's go down to the bottom one now. So it says write each expression in radical form, simplify if possible. Okay. So with radical form, we have to remember that if we have a to the m over n, then that means we get a radical. The n goes to the outside, and the m stays on the inside with the base. So for the first one, the 5 will go to the outside, and the 3 will stay on the inside. We cannot simplify this. And the reason that we cannot simplify it, and the easiest way to look at this is, okay, can I take 5 out of 3? You can. So you cannot remove anything from under the square root. Let's look at the next one. Here, I want you to recognize a couple things. One being that this entire thing is being raised to the 3/2. So when you go about doing this, here's your radical. The 2 is going to go to the outside, and you're going to get 9a to the 3rd. Notice I kept the parentheses. Okay? Now, question. And I'll break it down another way for you to look at it. Can you get a 2 from this 3? The answer is yes. Okay? So and you can do it once. So because you can take 9a out, like you can get a square out of that, so you would get 9a. This would be a square, and be left with a 9a on the inside. Let me explain this. I'm going to show you another way to break this down. If you ever want to know if you can simplify what's under a radical, what you want to do is see how many times that you can take something to the power of whatever's on the outside and break it up. So, for example, you have 9a to the 3rd, which means that you can do 9a squared times 9a to the 1st. Notice I have one 9a squared, so I can pull that to the outside, and you are then left with one 9a on the inside. This would be your simplified. Okay, now, difference here that I need you to recognize is that this is the only thing, the x is the only thing that has the exponent. So I can separate this as 3 times x to 2/7. Okay? The 3 will not be under the radical. So you will get 3 times the 7 comes to the outside. The x squared goes under the radical. Now, can you get an x to the 7th out of x squared? No, you cannot. Thus, your answer will be 3. That is your final answer. Okay, let's look up. All right, so 22. Now, 22, notice with 22, this entire thing is being raised to the 1/2. So, what's going to happen is the 2 is going to go to the outside. Let me change colors. The 2 is going to go to the outside. And I get 16x to the 4th. I'm taking the square root, okay? I'm taking the square root of something. So looking at this, I can take the square root of 16. The square root of 16 is 4. I can take the square root of x to the 4th. Remember, you want to try and divvy this up, so you could get x squared times x squared. How many times did you get x squared? You got them twice, so you would take out an x squared. That's your final answer. Okay. Again, what do we see with our eyeballs? Notice here is the only thing that has the exponent. So it's going to be negative 2 times, the 3 is going to come to the outside, 3x to the first. You cannot get a 3 from a 1, so that this is simplified as it's going to be. Okay. Now, we're going to go backwards. We can't simplify, and we're going to simplify if we can. So, again, you can do this, you can simplify before or after. I always say before because that'll probably make our lives a little easier. So if we look at this, you can't do any simplifying here. You cannot get the 7, you can't take a 7 from a 4. So, the 4 remains up top, the 7 will come back underneath. Final answer. Here, cubed root. We're taking the, let's look at this. Can you take the cubed root of 27? The answer is yes. The cubed root of 27 is 3, so that's going to come to the outside. Can you get 3 from 15? Yeah, you can get 3 from 15 5 times. So you get 3a to the 5th. That's your final answer. Okay, and there's no reason, this is in exponential form. We don't have to change anything. So I always think it's easier to simplify before you do anything else. Okay. 27. Here, there's no number here. So when there's no number, we assume that there's a 2. I'm going to show you the other way that I do this. So because there's a 2, I'm going to see how many 2x to the 2s, like 2x to the squared that I can get. Which would be because if we remember our law of exponents, if I were to combine all this, I would get 2x to the 6th, right? Well, how many times do I have 2x squared? I have it once, I have it twice, I have it 3 times. So the square root of 2x all raised to the 6th power is 2x to the 3rd. Which makes sense, because if we did it the other way, right, if we just went straight back into the fraction form, you would get 2x, this stays on top, this comes back to the bottom, 6 halves. Well, what is 6 halves simplified? 6 halves simplified is 2x to the 3. Same thing. All right, let's take a look here. Please remember that this has its own exponent. Okay. I'm going to not simplify this first and just go right into exponential form. Okay. So if that's the case, then this 3 is going to come under here, and this 3 is going to come under here, giving you x to the 1/3. Y, 9/3 can simplify, so I get x to the 1/3. 9/3 simplifies to 3. final answer. Square root. Okay. Let's simplify before we go. Okay. Another way I want you to look at this is you could also, remember this is all multiplication, right? So you could break this all up into its own separate thing. So you could do the square root of 9 times the square root of a to the third times the square root of b to the seventh. If it's easier for you to look at it like this. Okay, square root of 9 is 3. If we want to take the square root, okay, from here, we turn our fraction, so we get a to the 3/2, and then b to 7/2. So you get 3a, b to 7/2. Final answer. All right, put a 2 on the outside. We get 7 to the 1/2 x to 4/2 y to 3/2. We can do a little simplifying here. We're going to go 7 to the 1/2 x squared y to 3/2. Okay.